Hey Mustangs, this is Miss Otter. This is going to be the Math Spiral review for May 19th and 20th of our Phase 3 distance learning. So I'm doing these two pages. Let's go ahead and get started with the first one. It says Paradise Elementary School collected 28,450 cans for the food drive last year. This year they collected 35,730 cans of food. How many more cans did the students of Paradise Elementary collect this year than last year? So the key phrase to know here is how many more. When you see a phrase like how many more, it generally means that you need to subtract. So we're going to go ahead and subtract, keeping the bigger number on top. We have to go ahead and subtract this number from this number, but again, keeping the bigger number on top, so I'm going to put 35,000 on top. And subtract 28,450. Okay. Again, we always start our subtracting in the ones place, so 0 minus 0 is 0. 3 minus 5, I can't do that, so I'm going to borrow from the 7 and make it a 6 and make this 3 into a 13. 13 minus 5 is 8. 6 minus 4 is 2. 5 minus 8, I cannot give you $8 if I only have 5, so I'm going to borrow a little sugar from my neighbor, 3, make it a 2, and make this 5 a 15. Okay. 15 minus 8 is 7, and 2 minus 2 is 0. So this is the total difference. How many more cans did they collect this year than last year? They collected 7,280 cans more. Whew, good job. Okay, this next one, because this math problem is a triple digit, meaning 3 numbers, and a by double digit, meaning 2 numbers, we're going to go ahead and solve this using the area model. So I'm going to make some, oops, not a circle, that's not good. Let's go ahead, let's make a square. Okay, change that. Okay, so with my square, I'm going to go ahead, I'm going to divide it up into 3. Okay, for this number right here, and then in 2 for this number right here, and I'm going to split them apart into 800 and 20 and 4. I'm going to split up 73 into 70 and 3. So 7, I'm going to start in this top square here. So 800 times 70, well 8 times 7 is 56, and then I need to add 1, 2, 3 zeros to the end of that for 56,000. 800 times 3 is going to be 24 with 2 zeros for 2,400. 70 times 20, 7 times 2 is 14 with 2 zeros at the end is 1,400. 20 times 3 is going to give me 60. 70 times 4 is going to give me 280, and 4 times 3 is going to give me 12. My last step when I'm done figuring out all these is going to be to add. I'm going to zoom, actually let's zoom in just like this. I'm going to put it over on the side here, so I'm going to add up 56,000 plus 1,400 plus 2,400, let's see, plus 280 plus 60 plus 12, and they can be done in any order, but you need to make sure that your ones columns line up. So my ones column, I have 2. Then I have 8, 9 plus 6 is 15. Put down the 5. Regroup the 1. 4 plus 1 is 5. Plus 4 is 9. Plus 2 is 11. Put down the 1. Regroup the other 1. 6 plus 1 is 7. 8, 9, 10. Put down my 0. Regroup my 1. 5 plus 1 is 6. So our answer then to 824 times 73 is going to be 60,152. All right, where would you plot 7 tenths? I almost said 7 tenths. It is kind of the same thing, though. Where would you plot 70 hundredths on this number line? The reason why I almost said 7 tenths is because I'm looking at the number line, and I see that it's in the tenths place, and this number happens to be in the tenths place with the 0 being in the hundredths. So what I'm going to do here is I'm just going to treat this number line like it goes from 0 to 1, with 5 being in the middle, so 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths, or 1 whole. So when you look at it this way, this is what it's showing you. This is how this number line is breaking down. I may run out of room a little bit. This looks deceiving because it's asking you for 70 hundredths, but as long as you know that you can take this 0 off here, this becomes 7/10. So this number is actually going to go right here on your number line, on top of 7/10. Because again, you can have 7/10 or 70 hundredths, and they're going to be the same thing, because for this one, you just take off this 0, and you're left with 7/10. Okay. Next, Victor tried to find an equivalent fraction for 3/4. Below is his work. Can you describe his mistake? So a lot of students assume that because he started with this fraction, that was the mistake, but it's not, because that's okay. What this is trying to show you is that 3/4 is the same thing as 3/4 times, which should give you an equivalent fraction. So these equal signs are supposed to tell you that these things are all the same. However, his mistake in this problem is actually right here when he did 3/4 times 1/2. Actually, I'm going to change that to green. When he did 3/4 times 1/2, he was making a different fraction. Therefore, 3/8 is not an equivalent fraction. So this fraction, 3/4, is not equal, I'm going to put a sad face, not equal to 3/8. So his mistake is that he did not multiply 3/4 by 1/2. If he had done it correctly, he would have done 3/4 is the same thing as 3/4 times by, and we have to do same number over same number to show that it's an equivalent or equal to 1. So he could have done 2/2. His mistake is that he did 1/2 up here. Okay, so 2/2 equals, and now it's not going to equal 3/8, it's going to be 4 times 2, which is going to be 8. So that part is the same. And then on the top, though, we're going to have 3 times 2, which is not 3 anymore. It's going to become 6. So what this equation is saying is that 3/4 is equivalent to 6/8, meaning that they're the same thing. Okay, so his mistakes, what you can describe his mistake as, is that he was not multiplying by 1/2. Victor did not multiply by 1/2. Okay, that's his main mistake. He multiplied by 1/2 instead. Okay, this one I think is so easy that you may feel like you did it wrong, but I promise you didn't. Can you name the place value of each number? So the place value for 4 is going to be 4 hundredths. It's literally written out there for you. So hundreds. And then again, the 1 is in the tens place. So you have tens. The 6 is in the ones place. So it's in the ones. Then you have the 8 in the tenths. So you would write TENTHS for tenths. That's super important. And then you would have 300ths, so you would write 100 with a THS at the end for hundredths. And that's it. It was literally that easy. Okay, circle the figure that has at least one line of symmetry. So symmetry means that if you were to cut it down the middle, it would be the same on both sides. So if I cut an X down the middle, that's going to give me a line of symmetry, so A is correct. I could also cut the X this way and it would work out as well. For B, there's no way to cut this down the middle and have it be the same either way, so B is not an option. For C, there's no way for me to cut this down the middle and make it the same on both sides, so C is not an option. And for R, there is no way for me to cut this also down the middle and to make a line of symmetry or the same on both sides like a butterfly. So this is also not an option. So the only one that would work would be X. All right, moving on to May 20th. Which of the numbers round to 125,000 when rounded to the nearest 1,000? So I'm going to go ahead and I'm going to highlight my thousands place value right now so that I don't forget. And then we're going to talk them through. So with A, I want to see if it rounds to 125,000. I see that I already have 125,000 here. So if it rounds up, it's going to be too big, but if it stays the same, it's going to be fine. So this 5 is going to look to the 6 to ask it what to do. Since the 6 is a 5 or more, it will up the score of the 5, meaning changing it by 1 to make this 126,000, which will not work. So let's try the next one. On this one, the 4 is going to look to the 5 to tell it what to do. And the 5 is going to up the score of the 4 because it's 5 or more. So now we have 125,000, which will work. So this is a possibility. In the next one, we have 125,317. The 5 is going to look to the 3 to ask it what to do. The 3 is a 4 or less, so it is going to let this 5 rest, which means it's going to stay the same. So this is going to round to 125,000 as well. So this one works for us. For the next one, the 4 is going to look to the 3 to ask it what to do. The 3 is going to tell that 4 to rest. So what's going to happen is this is going to stay 124,000, which is not what we wanted. So D is not going to work for us. And last but not least, we have the 125,790. The 5 is going to look to the 7 to tell it what to do. The 7 is a 5 or more, so it will up this 5 score to 6, leaving us with 126,000, which will not work. So the only two that were possible answers were B and C. All right. Find the difference between 438,401 and 114,032. The difference means that we need to subtract. So I'm going to go ahead and subtract with the bigger number on top. 438,401 minus 114,032. So when I do this problem, there's going to be a lot of zeros skipping. When I look, if I have $1, I can't give you 2, so I'm going to go to my next door neighbor, which is unfortunately also a 0. So I'm going to cross out this 40, make it a 39, and make this one an 11. So then 11 minus 2 is 9. 9 minus 3 is 6. 3 minus 0 is 3. 8 minus 4 is 4. 3 minus 1 is 2. And 4 minus 1 is 3. And there you go. All the borrowing happened right at the beginning. Okay, use a number line to plot the following decimal. 0.2 or 2/10. So I'm going to make just a really easy number line. I'm going to go from 0 to, because I see that my number is 2, I'm going to go from 0 to 4/10 just for fun. So I'm going to start with 0, 1, 2, 3, 4. So this is 1/10, this is 2/10, and this is 3/10. And I'm going to go ahead and let's see, to plot the following. So where does this 2/10 go? It goes right here on the number line. That's all you had to do. You just had to make the number line yourself. Okay, Trevor recorded how many hours he read each day for 7 days. The total was 8 hours. Create a possible line plot. So there are so many different combinations you can do with this, but you have to have these stipulations. Because it says he read for 7 days, this means that you need to have 7 X's on the plot somewhere. So 7 X's on the plot. Okay. The other bit of information that we need to keep track of is that the total is 8 hours, meaning that all 7 X's have to add up to 8. Okay. So now let's go ahead and let's plot our X's. So I'm going to kind of, as I do this, I'm going to add them up in my head. So I can have a half an hour plus a half hour is 1 hour, 1 hour, 2 hours, 3 hours, 4.5 hours, 5.5, 6 hours, and 7, 8 hours total. So with this kind of line, you're looking at 8 hours total here with 1, 2, 3, 4, 5, 6, 7 X's with a total of 8 hours. This is, again, not the only combination you could have done. You did not have to use all of these, or you could have used some of them or all of them. This is just one possible solution. All right, for the next one, 1 3/10 represents the fraction 1 3/10. What decimal represents 3/10? Now the trick here is that these fractions, when they're sideways, they look kind of wonky. So I'm going to go ahead, I'm going to rewrite this fraction as 1 3/10. I'm going to write this as just 3/10. So when looking for what decimal represents 3/10, we don't want anything in the ones place because this is missing a whole number. So I'm going to cross out the ones like C with the whole number. Okay. My next thing that I'm looking at is that I see that 1, so I need to represent this in decimal form for 3/10. When I look at A, I see that there's a 3 in the hundredths place value and nothing in the tenths, which means that this is incorrect. When I look at B, there's nothing in the ones place and this 3 is in the tenths place. So B is correct for 3/10. And D, when you're looking at this, this is actually 33 hundredths because this last 3 right here is in the hundredths place value. You would write this fraction this way, so this is not going to work either. So the only one that's going to work is going to be B. All right, label the objects: parallelogram, rectangle, square, rhombus, or trapezoid, and use each word once. So I'm going to go ahead and start with the super obvious ones in my Julian blue, and I'm going to label the square, which is right here. Okay, next I'm going to go for the next easiest one and label the rectangle, which is down here. Okay, and then I'm looking at something else that I know really well, which is a trapezoid, which is going to be here. Okay, so now I have 2 left over. Hopefully you remember from class that a parallelogram means that it has 2 sides that are parallel to each other. So this shape is going to be a parallelogram because parallelograms don't need to have 90-degree angles. Not that they can't, but they don't need to. And last but not least, that leaves a rhombus. So here at the top is a rhombus. Okay, that is it for these 2 math pages. Hope that helped, and I can't wait to see your work when it gets turned in.